In this part of the course, we're going to cover direct broadcast satellite systems. Now, these systems are also referred to technically as Ku-band DBS systems, due to the designation of the 12 GHz downlink spectrum it uses as the K sub U or Ku microwave band. Source television signals are converted to a digitally compressed MPEG-2 data stream. The data stream is transmitted on a 17 GHz uplink carrier to a geostationary satellite. In the satellite, the received signal is converted in a device called a transponder to a 12 GHz downlink carrier and broadcast over a wide geographic area visible by the satellite. The signal is received by a small high-gain dish antenna pointed at the satellite and connected to a specialized receiver. The receiver converts the signal from an MPEG-2 data stream back to the original analog form for viewing on a local television. Satellite service in the U.S. seems to be constantly changing. But at the time we made this course, there were two major suppliers of DBS service: DirecTV, owned by Hughes, and the Dish Network, owned by EchoStar. The dish receiving antennas for both providers look similar, but differ in how they convert arriving signals for the receiver. DirecTV antennas are equipped with 1 to 3 LNBs to receive the network signals from satellite transponders at the 101, 110, and 119 degree orbital positions. New Dish Pro antennas are equipped with 2 LNBs to receive the network signals from satellites at the 110 and 119 degree positions. The LNB, or low noise block converter, converts the received 12 GHz band of downlink signals to an intermediate frequency band from 950 to 1450 MHz. Power for the LNB is supplied by the receiver over the same coaxial cable used to feed the signal to the receiver. For DirecTV LNBs, the voltage level is used to select the odd or even transponder channels, carried on the left or right-hand circular polarized signals, respectively, from the satellite. Dish Network LNBs incorporate a European standard called Digital Satellite Equipment Control Technology, or DISEC for short. It allows two-way signaling between the LNB and the receiver. Now, both even and odd transponder channels are output at the same time using 2 blocks of intermediate frequencies, 950 to 1450 and 1650 to 2150 MHz. There are 2 approaches to installing multiple receivers in the same home. The obvious is simply to install a separate satellite dish antenna for every receiver. The other approach is to allow one antenna to be shared by multiple receivers. To do this typically requires a device called a multi-switch. Basically, a multi-switch allows every receiver to view any transponder channel on any satellite that the antenna can see. A typical DirecTV multi-switch receives the polarity voltage and a tone from each receiver and switches the appropriate left or right channel from the correct LNB to that receiver. This requires a dual output LNB. The LNB has 2 connectors that output the left and right-hand polarized transponder channels at the same time. These are very common on new satellite antennas. DirecTV multi-switches typically have 4 inputs, the left and right-hand outputs from 2 LNBs, and 4 to 8 outputs for receivers. Multi-switches for the Dish Network have 2 inputs for the dual LNB that supports both primary satellites, and an extra input for a secondary dish. This model supports 4 receivers, but is cascadable to support up to 12 receivers. Since multiple receiver installations are so popular, many manufacturers of multi-LNB dishes are building them with multi-switches built in. This 3 LNB DirecTV dish from Turk has a multi-switch built in which will support 4 receivers. This Dish Pro quad output dual LNB allows up to 4 Dish Pro compatible receivers to share the same LNBs. Unfortunately, multi-switch and LNB designs are constantly evolving. Even the satellite and transponders change. So make sure and check that the LNB and multi-switch technologies you're using are compatible and recommended by the services you're using. Where is Richard? Now that we've covered sources, let's cover how they're combined in the distribution device. Now, incoming off-air cable service is split to support branch cable runs to outlets throughout the home. Let's first cover some component characteristics you'll need to know, starting with splitters. A splitter divides an input signal equally between two or more output ports. They typically come in 2, 4, 6, and 8-way versions. They're also referred to as a combiner, since they're bidirectional and can be used to combine two or more signals. They may or may not be DC passing, that is, they may pass a DC signal either for power or IR signals over the coax. Because they divide the signal, they divide the power or amplitude between the outputs. The outputs of a two-way splitter are typically 3.5 to 4 dB less than the input. Your workbook has a table